Welcome to the virtual launch event for the HPE 5G Lab. Located in Fort Collins, Colorado, the HPE 5G Lab provides a standards-based environment for testing, validation, and proof of concept demonstrations of multi-vendor 5G solutions, a neutral proving ground for independent solutions providers. And to mark the virtual opening of the HPE 5G Lab, we are hosting two special panel discussions, bringing together HPE executives and their partner companies. And you can get involved too. Please send in your own questions to our guests. There's a form here on the HPE channel on the TelecomTV website, along with a quick poll that we would love you to complete. We'll be back to continue this discussion in the coming weeks, when we then look forward to answering your additional questions. Now though, joining us for our first program, I am delighted to introduce Jeff Edlund, CMS Chief Technology Officer at Hewlett Packard Enterprise, Azhar Sayeed, Global Chief Architect at Red Hat, Amit Tiwari, Chief Strategic Alliances Officer at Affirmed Networks, and Shubho Chowdhury, Director Product Management Wireless Core Portfolio at Casa Systems. Hello everybody, thank you so much for joining us. Good to see you all.
Good to see you guys.
Good to be here.
Before we start, Jeff, can you give us some background, please, as to HPE's strategy towards the 5G core?
Yeah, certainly, Guy. So, when we were contemplating what we were going to do in 5G, it became very apparent to us from the start that we needed to take a clean sheet of paper and really design our 5G solution from the ground up, taking advantage of the inherent and native features within cloud technology. So that's exactly what we've done. And our strategy has always been in HPE to be a partner-forward company. So we take the best things that we do and we combine them with our partners and the things that they do the best. And through that effort, we have created an open multi-vendor 5G solution that can very rapidly be deployed and frankly be modified for a particular customer need for service providers around the world.
So, Jeff, the HPE 5G core stack is a pre-integrated solution. It comprises components that some are from yourself, some are from your partner companies. They come together, but how do your telco customers know this is all going to work?
So that's the beauty of the lab. The lab, one of its very important purposes is to bring all of these partners together in a centralized complex, be able to do the testing and the validation that from an interfacing perspective, everything is behaving as it should. Be able to do performance testing, or what I call a run for pink slips, so that we can actually characterize, how much traffic can you throw through this, and then be able to capture all of this integration, validation into supportable configurations that HP and its partners can stand behind. We can hand off the documentation and the solution to our telecom customers and say to them with confidence, this is tested, validated, and we are in a position to support this for you.
Thanks, Jeff. Well, let's ask your partners. Amit, let's start with Affirmed Networks. How are you involved and what's your view for the next steps of 5G core interoperability and automation?
Sure, Guy. We at Affirmed Networks have always believed in the power of a rich, diverse ecosystem, which brings the best of breed solutions into an ecosystem which then creates the best of suite solution for the service providers, right? 10 years into this journey, first to virtualize service provider networks, and now with the cloud native offering, providing a microservices-based decomposed architecture, a very key value tenet of a solution that goes into service provider networks is pre-integration into an open ecosystem that is then ready to be actually deployed into an MNO environment, right? So this is a very welcome happening for the industry as a whole. So we welcome this a lot.
Well, let's continue this theme. Shubho, I'm going to ask you about Casa Networks and your experience with working with the multi-vendor 5G core.
Yes. From the service provider side, we are seeing increased demand on a multi-vendor environment because I think for security reasons and for innovations, the operators don't want to do vendor lock-in. They are looking for 5G to be multi-vendor environment, and we're seeing increasing demand on that for integrating with different vendors. So I can tell you one of the major multi-vendor proof of concept we recently finished with HPE and Casa Networks with collaboration with Orange Labs. So what we did actually, we dynamically created slices, and these slices are on demand and based on automated connectivity recovery. So when you have some glitches in the network, the dynamics is created and then the workload is moved to the new slice. And that is possible because the true cloud native environment and a multi-vendor environment, you should be able to create dynamic slices and then be agile in service innovations, right? So those are the key points that operators are looking for in 5G particularly.
And Azhar, as I understand it, Red Hat is providing part of the infrastructure. You're providing your container platform as a service, is that right?
Absolutely, Guy. As far as the OpenShift platform goes, first of all, Red Hat's route to market is through partners. And we pride in creating a vendor neutral platform that allows us to onboard any of the network functions from our different partners to provide that capability and service. So in this case too, we've worked very hard with our partners, with HPE, with the firm, with Casa and others, to actually build this particular platform so that they can onboard their network functions on top of that particular platform for 5G. And this is OpenShift as a container platform. And what we have done is built it, tuned it to allow these things to run much more efficiently and much more smoothly.
Jeff, why do we need this multi-vendor interoperability testing rather than just individual testing against the agreed standards?
Well, I think the important point here, Guy, is that if you don't want to have a completely vertically integrated black box, our customers are expecting that we will have integrated, tested, and validated configurations before we go to lab entry within their environments. And so that's a fundamental value that this lab can bring, rather than telling our customers, trust us. Everything has been packaged for you and you put things in the top and they come out the bottom. We bring our customers a solution that is built out of microservices. It's cloud native. We've done all of the testing and the validation up front. We can provide documentation to that. And we can also certify to our customers that this is supportable and meets the needs of what they're asking for their particular 5G network solution.
Shuvo, you spoke earlier about cloud native and the fact that your network functions are cloud native. What does cloud native mean to you?
I think we need to understand the cloud native, very important part of the 5G core, right? So cloud native means that it's not lifted and shifted software from VMware. It's a pure CNF that can scale as the cloud structure scales, right? So it can be as small as that can fit to very tiny space in the edge compute, or it can scale as big as to the cloud in a multi-cloud environment or even the public cloud environment, right? So CNCF actually recommended different types of cloud native environment CNF. It can be normal cloud native that's lifted and shifted. It could be silver grade, some kind of cloud native, but not embracing the true cloud native environment. And the third one, they tried to call it gold CNF, right? And gold CNF means that it embraces the true cloud native environment. It uses Kubernetes operators to scale. It uses all the security features that Kubernetes or Red Hat OpenShift offers, right? So embracing a true cloud native 5G core we are embracing the true recommendations that CNCF is offering through the Gold CNF. And CASA CNFs actually embrace those, and we actually seeing that operators are very interested to see true cloud native softwares that enable the 5G core.
Great. And Azhar, it seems that we can't talk about 5G core without also referring to cloud native. The two seem intrinsically linked.
In many ways, because most of the implementation, in fact, all of the implementations, if you see, they are building to this services-based architecture, which is cloud native. All of our partners that we've been working with in terms of 5G core implementations, they are doing that. Part of it also is the way 5G core has been, standardized in terms of an overall services-based architecture, where you have control plane elements, you have data plane elements that are completely separate. And if you want to really truly gain the efficiency of 5G in terms of what the promise of 5G, which is very wide scale, very large number of sessions, and ultra low latency and reliability, then you have to have an implementation that's really good. And cloud native can provide them with all of these attributes that allow them to actually realize the full potential of a 5G core and 5G infrastructure. So it just makes sense. Also 3GPP's recommendations, or NSC implementations, and looking at TIP and number of bodies, all of them are actually advocating for a cloud native architecture for 5G implementations.
Thanks, Azhar. Amit, how do you see the importance and relevance of cloud native here?
This is a really key component, Guy, right? And just like Azhar was saying, if you think of I'm going to go back a little bit. In the early days of the IETF, if you remember, Guy, a lot of the innovation that was driven, through the scale of the internet from those days on was needs driven, right? We had a certain vision of how we wanted, back then, put a computer on every desk, and now it is a mobile with everything that you can think of doing socially, work-wise, for fun, on your handset, right? If you think of 5G as what it looks to drive forward, and then you think of cloud native, see, cloud native actually is the means to meet the promise of 5G, right? And by that, what I mean is, we're talking about massive bandwidth, pervasive computing, every handset, every device being always on, communicating not just to the network, but actually communicating with each other, right? How do you actually scale to that level of ubiquitous, pervasive computing without the tenets of what we do with cloud native, right? I mean, you can see, what drives microservices. You can see what drives control user plane separation, right? You can see why, Kubernetes becomes so critical. You can see why scaling is so fundamental to meeting the promise of 5G type services, right? So, think about this. With that grand vision, if we try to retrofit, right? And, there are terms that, you hear about, cloud washing, for example, right? Actually retrofitting a VNF architecture into CNF. All of those, these are humongous penalties that you end up paying. These are humongous tax that you end up paying to actually now convert into a quote unquote cloud type architecture. It is fundamentally different than a clean sheet of paper architecture. Cloud native from the get-go, leveraging all the tenets of CNCF and creating a real cloud native architecture, which then translates into all these benefits, right? Massive throughput, ultra low latency, pervasive computing, being able to scale like the cloud, like the cloud application scale. That's what really gets us to the promise of 5G, and that's why cloud native is so critical to it.
Thanks. And Jeff, we've heard a lot of benefits there of going cloud native in 5G core. How do you think an open cloud native model improves the security of 5G networks?
Well, so the cloud native model allows you to break the network into small microservice components. And you have a tremendous amount of observability of what's going on between the interplay of all of the different services. And there's really nothing like shining the light of day through observability on what's going on between these interfaces to be able to secure the solution and understand what's actually happening and be able to eliminate bad actors or other problems that you would see going on within the context of the cloud native core.
Security is such a key component, of 5G and cloud native deployments and architectures, like Jeff said, Guy, right? One of the things I like to highlight is, when you think of 5G networks and where we are headed, billions of devices connected in all across the world at different geos and different network types, right? So think about it. This is the attack surface for bad actors becomes pretty significant, right? So the way you solve this is also very different than in the legacy, approach. So again, talking about cloud native principles, baking security into the design and architecture of the CNFs per CNCF recommendations, as well as the design of the network and how they are run, makes it's like quality, if you remember, right? Baking quality into the process is actually so much more efficient than doing it at the back end. Same thing in 5G and cloud native architectures, making sure that security is actually a fundamental part of the process, makes certain that all kinds of rogue devices or actors are not able to exploit the larger surface that is now presented with these networks, right? So again, building this into the process helps us get to more secure and scalable networks.
Can I move on to the importance of innovation? And Azhar, I'm going to ask you this question first. The HPE 5G Lab is encouraging a lot of partners to come together, encouraging to test, to innovate. What is the importance and value of open innovation when it comes to 5G?
If you look at the number of components, software components that are involved in a 5G implementation, take 5G Core, take 5G RAN, these components are coming from different vendors, different partners of Red Hat. They need to be put together. I think Jeff or Amit said it earlier in terms of you want to go to a customer that's with a pre-integrated solution, but at the same time providing a choice to the customer to be able to put any component in place and build it as part of the common horizontal platform. So then the question becomes, because you're taking these different components from different vendors, the telco has a choice to pick best of breed in each. So that's one. A second, because it's a cloud native platform, you have the opportunity now to create and add value through better data management, applying analytics, creating a closed loop system. And you can innovate based on these new capabilities that were not possible in a single vertical stack. By bringing in these type of different components, different solutions together and building a service and offering new capabilities to your customers. And of course, 5G architecture lends very well to deployment of edge compute. Now, edge compute opens up a completely different segment for a telco, a completely different area in terms of how they can add new services, how they can innovate in their environment to provide new capabilities to the subscribers.
Azhar, how is Red Hat's OpenShift platform optimized to run on HPE's telco blueprints?
So we've been working with our partners to optimize the platform to run these type of 5G workloads. And the conversation we've been having with HPE for some time now, in order to actually tune that platform and make sure that these workloads, when they're onboarded on the platform, are really running much more efficiently. So some of the functionality we've worked to enhance as part of the platform is based on the work we've done upstream in open source communities with Kubernetes. And then the subsequent steps is to now tune the platform to be able to actually really leverage the power of it. So new functionality in terms of forwarding performance, in terms of CPU isolation and management, in terms of Kubernetes scheduling, and in terms of building things like what Shivo mentioned earlier around operators. So operators allow you to lifecycle manage these components. And those operators are, capabilities built into the OpenShift platform. So these are the things that come together to really enhance the deployment experience and the management experience of the 5G core platform. And that's what we've done as part of OpenShift.
Great. And Shuvo, I'd like to come to you at this point because you've already spoken very briefly about network slicing. So what's your view on this and the move to edge and how a telco can reconcile all this with the need to still keep their costs low?
Yes, I think in 5G, one of the most important aspects is innovation because, as I explained before, before the telco network is built for 5 nines, right? You are focused on 5 nines, and that breaks a lot of economics, right? So in slicing, that gives you flexibility to build a network that could be 2.9, 3.9, and sometimes it could be 6.9 for ultra-reliable communication, right? So you can slice and dice your network as you wish, and then make your commercial offering based on the slices and SLAs, right? So those kind of capability in 5G now gives you to build differentiated services. And when you build differentiated services, you need applications to support that, right? So that, as said, that 5G will be driven by the new application revenues, not by the mobile throughput itself, right? So you have to innovate to have a sustainable 5G, and to actually looking into that. And edge is also important, right? So I go back to the cloud native again, that if you have built an edge and the slice that is very, very small to take care of the edge compute, and then it can grow as big as a cloud environment, right? That's very important because in 5G, you build some application that could be running extreme edge in a very tiny environment, or it can run in a very, very big cloud, like a post-processing, right? So that's why the applications that cater to particular slices is very important to understand for use cases for 5G.
Jeff, picking up on this thread of innovation, the need for telcos to adopt more service models and innovation in services, what are the new applications and workloads that we might expect to see coming out of HPE's 5G lab?
Well, I think first, Guy, I would say there's probably a lot of innovation in new services that are going to reveal themselves that we haven't even imagined yet. But one of the real beauties of this multi-vendor approach and this openness approach is that if somebody comes up with a better mousetrap for one of these NFs, as long as the interfaces going in and out comply to standards, it's very easy to plug a new vendor, a new innovation in an NF in there. And then from, adding on top of that, from a perspective of the kind of services that we can see, I would imagine that you'll see a whole new era of work being done where people are. There will be less of a tie to the office. You'll start to see a gig economy start to emerge where things like surgeons no longer have to be tied to a hospital. With robotic surgery, they can actually service many different medical systems and hospitals. Autonomous vehicles and autonomous driving and the connection of that autonomous vehicle to the city and the municipality where it's traveling. Being able to do interesting things in R&D like virtual Scrum, where everybody does their stand-up meeting together, but in a virtual space. These are some of the musings that I have that I think we could really see become a reality here in the future.
To the point that Jeff just made, this is there's a term, Guy, we used, within a firm, right? It's unleash the developers. Right. So, think about this. When we talk about a cloud native infrastructure, a cloud native architecture with pervasive computing that 5G is going to provide to us. I mean, essentially, think about this, the network now extends everywhere. And just like on the cloud, you have these immense communities of developers who are focusing on innovation. That's what they worry about. They worry about how to create the most usable, user-friendly new types of applications, be it for the enterprise, be it for the individual consumers, so to say. All they focus on is innovation. And we talk a little bit about the edge as well, right? So I tie the two together. If you think about it, we architect this network correctly, as in having a very diverse set of areas where you actually can run the workloads, as in the enterprise edge, the carrier core, the actually public cloud, the hybrid cloud. And now think about this, what we just did. We actually allowed the developer to go out and write their apps, not worry about where they're going to be run, because that's what, all of us here on this discussion, right? That's what we're working about. We're talking about an architecture that is so flexible, it is so pervasive, and it actually runs on every form factor, right? We could be running on any form of edge, core, cloud, hybrid, or public, and then let the developers write their apps, and it can be run at the optimal place for the best user experience, right? See, that is the power of this network and this concept that we're talking about. It unleashes a whole, who would have thought, think about this, 15 years ago, who would have thought, you'd press a button on your phone and actually a physical car shows up, right? I mean, that's what the current network is getting used for. Just think of when we do this multi-fold more with 5G and cloud native deployments, the types of applications that will show up, it should really make, the world a better place. It really should.
So Azhar, we've got to get the network right, ubiquitous, working across all different scenarios, and then we can expect to see some of the applications and workloads that we probably haven't even thought of yet start to emerge thanks to our developer partners.
So I'd actually put a throwback quote in here from Scott McNealy when he said network is a computer. He talked about it in the context of internet. But, truly, if you see what's happening today, that computing power from those workstations and servers has now moved down to your handsets. And now mobile network is the new computer in that sense, because what Amit was talking about a moment ago is the ubiquitous computing presence that's there, the amount of data that each user is generating. And I think you and I have probably talked about this before, where the world has moved on from being consumers and producers to prosumers, where everybody's producing and everybody's consuming. So the amount of data this whole thing is generating, and the ability to manage that data, the ability to efficiently deal with large scale number of users, you require a platform that's capable of dealing with these. A horizontal platform where you're not gated by developing once for a cloud, developing another time for an edge, developing a third time for the user, developing a fourth time for, on-premise and so on. No, you can't do that. It's just not going to scale anymore from a developer experience perspective, from a deployment perspective. So you really need the ability to develop once to a common platform and deploy that anywhere across the entire spectrum, from core to the edge, to the far edge, to the on-premise, to even devices. And that's what really can drive an open ecosystem like this, and a common platform like this can really help drive.
Great. Jeff, I'm going to ask the final question to you, and tying all this together. Why do we now, as an industry, need to move to this open software-based model? Why do we need to encourage this open ecosystem, and how is HPE playing into this with the launch of its 5G lab?
Well, I think to the why, it's all about velocity and speed. If you look at any market, everything is moving faster. In particular, the telecommunications industry is moving at a pace that I think we knew was coming at us, but no one had fully embraced. And how HP can help here is by putting this lab in place, having these best of breed partners that we've assembled and giving the entire industry a place where they can come get together and rapidly not only trial the core parts of the 5G solution, but start to bolt the solution, bolt services and applications on top, and figure out what's possible and bring the what is possible to market much more quickly than the snail's pace that we saw in 3G, the little bit increased pace that we saw in 4G. But 5G is going to really unleash via cloudification and via all of this openness, the rapid introduction and innovation of new services. And HP is here to help embrace that innovative future, to help match the speed and velocity that this needs to occur at, bring our partners and customers together, and provide a place where we can actually very rapidly bring these new solutions into reality and then ship them out to the telecom customers so that they can touch the rest of the world with these services and solutions.
Well, thank you very much, everybody. Appreciate you sharing all your views, and hopefully our audience will have many more questions for you later. Don't forget to watch our second panel discussion with HPE, OpenNet and Metaswitch. That's right here on the HPE channel on TelecomTV. And as we've just mentioned, we also want to hear from you. If you have any questions that you would like to put to our panelists, then please do so now. The question form and accompanying viewer poll is accessible on the HPE channel, along with links to plenty of supporting materials. So send in your questions to all our guests, and we'll be back in the next week or so to continue the discussion. But for now, thank you for watching and goodbye.